Okay, for these first couple sections of Unit 3, I am just going to summarize them because they're really just some prior content that you're supposed to remember before we get into the two main topics of Unit 3. In Unit 3, our two main topics are going to be special right triangles and right triangle trigonometry. So all of these sections, 3.1, 3.2, 3.3, and even 3.4 are just leading us up until these two main major topics. I cannot express to you how important these are for you for Math 3. So if anything was extremely important for you to remember, similar to solving quadratics from last semester, this is the unit. So let's get through these first couple sections, 3.1, 3.2, and 3.3 as a review. And remember that the Apex quizzes are optional. If you do the Apex quizzes for these, which are optional, it will count as extra credit. If you don't do them, it will not hurt you. So the study guides are mandatory. The Apex quizzes are optional. Okay, let's go through some prior knowledge and summarizing here with a couple of vocabulary words. We're starting with the first vocab of a right triangle. So remember that a right triangle is a triangle with one angle. One angle that forms 90 degrees. Okay, so picture drawing a right triangle. How do we know it's a right triangle? With that little mark in the corner. A triangle with one angle that forms 90 degrees. So now let's label the parts of this right triangle to see if you remember these terms. Remember that we've got this longest side right here that we call the hypotenuse. And that is your longest side. It is also the side across from the right angle. Okay, so what were the other two sides called? Do you remember? Good, those are your legs. So this one's a leg and this one's a leg. The two legs are along either side of the 90-degree angle. Okay, now we've got some fill in the blanks with those same words down here with what we just said. The hypotenuse is the side opposite the right angle, and the hypotenuse is always the longest side of the right triangle. Okay, let's go to the next page. In a right triangle, the sum of the squares of the leg lengths is equal to the square of the hypotenuse length. Okay, what's that called? Hopefully you remember this. Da, 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 da. It is a squared plus b squared equals c squared. This is called Pythagorean Theorem. And you should have learned this in middle school. So A is equal to the length of the first leg. B is equal to the length of the second leg. And C is equal to the length of your hypotenuse. The formula we actually expect you to use in high school instead of a squared plus b squared equals c squared is leg squared plus leg squared equals hypotenuse squared. Hypotenuse. How about I spell this correctly? Okay, so instead of having to rely on the fact that something's called A, B, and C, we just know that whatever the two legs are, the sum of those squares equals the hypotenuse squared. Okay, let's go do some examples. Follow the steps to find the missing side length. So I'm going to call this right here X. And actually we can call it C squared when we know it's the hypotenuse. Okay. So write the Pythagorean theorem, a squared plus b squared equals c squared, and then plug in the side lengths that we do know. We know that side length 1 is 8, so we say 8 squared, and that side length 2 is 15, so we put in the 15 squared. So square those side lengths. 8 squared is 64, 15 squared is 225, and add those together. We get 289. If you take the square root of 289 on a calculator, you will see that C, our hypotenuse, equals 17. And we always want to put our units. So if in this picture it doesn't say any units, we're going to say that the C value or the hypotenuse is equal to 17 units because it is a distance. Now, what if you go to take the square root of something and it's not a perfect square? You would then simplify the radical or use your calculator to get a decimal estimated value. We'll talk about that in the future. For now, let's keep going down here to the next section. All right, so here in a triangle, or if a triangle is a right triangle, then the square of its longest side equals the sum of the squares of its two other sides. This is the Pythagorean theorem. What's the converse of that? If the square of the longest side of a triangle equals the sum of the squares of the other two, then it is a right triangle. So we can also use this theorem to prove that something is a right triangle. So if I give you all three side lengths, we can test it to see if it's equal. So for example, since 20 is the longest side, we can say that 12 squared plus 16 squared equals 20 squared. And notice that 12 squared is 144, 16 squared is 256, and 20 squared is 400. Since 400 equals 400, we can say that triangle ABC is a right triangle because its side lengths satisfy the Pythagorean theorem. So we can actually use the given values to see if it is a right triangle, if it fits the Pythagorean theorem. Okay, now let's go talk about something called the Pythagorean triples. The Pythagorean triple is a set of 3 whole numbers that are the side lengths of a right triangle. And then below here, they give us some examples. So 3, 4, and 5 are Pythagorean triples. But we could also multiply those original by 2, and we would get that the new Pythagorean triples were then 2 times the original values, or 6, 8, and 10. So we could say that 3, 4, and 5 are Pythagorean triples, and 6, 8, and 10. Likewise with 5, 12, and 13, we could say that those are Pythagorean triples. But did you know that if we multiply that by 2, we can get some new values of 10, 24, and 26. So we could say that these are also Pythagorean triples. 8, 15, and 17. Again, if we multiply this by 2, we'd get 16, 30, and 34. All of these are Pythagorean triples. 7, 24, and 25. Multiply it by 2. That could be 14, 48, and 50. So it still works when you multiply by 2. Okay, here's what you're supposed to be able to do from middle school math or from Math 1 with the Pythagorean theorem. Let's go do some practice problems. Again, if you choose to do the Apex quiz after doing this, maybe you're like, hey, this stuff is kind of not bad. Maybe I'll take the Apex quiz for some extra credit. Remember, it's optional, but if you take it, it will give you extra credit. So here we go. The top 3 are missing the longest side, the hypotenuse. So that means as you set up this Pythagorean theorem, it's going to be leg squared plus leg squared equals hypotenuse squared. You're going for the missing hypotenuse. And actually, before we even write that, remember that we need the formula first. So then we go 14 squared plus 10 squared is equal to our unknown. So 14 times 14, do that on a calculator. 196 plus 100 gives us 296. And this is what I mean by when you go to take the square root of it, this time it's not a perfect square. So you'll see that you get something in the calculator that has to be rounded. And so 17.2 U for units is what I'm getting. Let me just feel free to do that in your own phone calculator or Desmos if necessary. Okay, going to the next one, we start with the formula. We go leg squared plus leg squared equals hypotenuse squared. Fill in the blanks, 9 squared plus 8 squared, and the missing longest side. That's 81 plus 64, and 81 plus 64 gives me 145. You're going to notice when you go to take the square root of this that this does not come out as a perfect square. So I'm getting 12.0 something. So if we round to that U for units, we'll stop there. All right, try the next one, see how you do. Make sure you have your phone calculator ready. I'm doing square root of 145 again real quick. 12.04 is what this came to, so I guess it is 12.0. Okay, so on this next one, let's go get a new color. We've again got leg squared plus leg squared equals hypotenuse squared. 7 squared plus 5 squared equals our unknown. 49 plus 25 comes out to 74. Take the square root of both sides. C is approximately 8.6 U for units. How'd you do? Okay, now sometimes we're not missing the longest side. Sometimes we are missing one of the legs. So you'll notice in this case that we're going to be filling in different spots here. So when I write out the formula, leg squared plus leg squared equals hypotenuse squared, we're going to be filling in an 8 squared and then the unknown. Notice the unknown is no longer after the equals, it's right here in the middle. So there's going to be a subtraction necessary in solving this one. So when I minus 64 from both sides, I get 80. And when I take the square root of 80 from both sides, I get that A, or my leg, is approximately 8.9 U for units. Okay, let's go try one on your own. Pause the video and do the next one for the missing leg on your own. Let's see how you do. Okay, let's go check it out. Did you plug things into the correct spot? And I'm getting A is approximately 11.2 U for units. All right, looking at our last two, it is again a missing leg that's going to require the subtraction. When I subtract 49 from both sides here, I'm going to get that A squared is equal to 32. And when I square root both sides, I get that A is approximately 5.7 U for units. And last, I'm going to get A squared plus 11 squared equals 16 squared. You're going to minus 121 from both sides. 256 minus 121 is 135. And when you square root both sides, you'll get that A is approximately 11.6 U for units. All right, last ones for questions 8 through 10. Determine if the triangle is a right triangle. So in this case, we're going to use the Pythagorean to verify if the right triangle is true. This is called the converse of the Pythagorean theorem. Okay, so here we're going to go root 63 squared plus 9 squared equals 12 squared. That's going to give me the square root of anything squared. Okay, that's just 63. Notice what happened there in their first part. Plus 81. If I add this, I get 144 is equal to 144. And so then you can say, yes, triangle ABC is a right triangle. Okay, let's go do the same thing for the next one. We're going to say 7 squared plus 5 squared equals 9 squared. That's 49 plus 25. And 49 plus 25 is 74. Does 74 equal 81? Nope. So triangle ABC is not a right triangle. And finally, we do root 29 squared plus 13 squared equals 14 squared. So 29 plus 169. And that gives me 198. And that does not equal 196. So triangle ABC is not a right triangle. So do you see how we used it in this case to prove the Pythagorean, if it was a right triangle or not? And that was it for the 3.1. Again, you have to remember how to do the Pythagorean theorem from middle school or Math 1 in order to fully understand our new topics coming in. How'd you do?